Hello grade 11 students. Today I am here to teach you an important geometry unit, that's Midpoint Theorem chapter 11 in your textbook. So here you need to know two theorems. One is Midpoint Theorem and the other is its converse. So we'll see what is Midpoint Theorem is. We'll take this example, a triangle ABC. And it says this length is equal to this length. So what about this point? That's the midpoint of AB. When you take this line, it says this length is equal to this length. What's that? That means midpoint of AC is Q. So we'll try to answer these questions related to this triangle. So you are asked to write down midpoint of AB. So what is midpoint of AB? It's P. What's the midpoint of AC? Q. Third side of the triangle. Now, when we take these two sides, the next side, the other side we call the third side of the triangle. So here, what's the third side of the triangle in this one? BC. So you need to know these terms. What is third side, midpoints, AP. When you take the length AP, we know AP is equal to PB. Then what's AQ? AQ is equal to QC because this length is equal to this length. Then line segment through midpoint. So what is line segment through midpoints means? When we connect the midpoint of this and this one, we call this line is the line segment through midpoint. So I can write for this example, that's PQ line. So you need to know in a triangle how we identify these terms, midpoint, third side and line segment through midpoints. We'll take another example. PQR is a triangle and it says this length is equal to this length and this point is Y. Here these two lengths are equal. What's the midpoint of PQ? What's the midpoint of PQ? That's Y. Midpoint of QR? What's the midpoint here? You get X. Then what's the third side of the triangle? Here, midpoint here and this one. So then other side, we call the third side of the triangle is PR. Then what is QX is equal to? XR. QY is equal to YP. Then line segment through midpoints. What's the line segment through midpoints? That's XY. Now we'll take a small construction. So take your ruler and measure 8 centimeter length. And then take the protractor, measure 30-degree angle and you draw the BA line and then measure 6 centimeters and you mark the point A. So this is the triangle you need to construct. Do that and see. So then take half of it. That means 4 centimeter away from this. Mark the point X. That's the midpoint of BC. Here 4 centimeter. And then what you have to do? Take the other side. That means midpoint of BA. We'll take as Y. That's 3 centimeters away from B. So mark the Y point and connect X and Y. Now you have to check these things. Measure XY length, measure AC length, and then measure BXY angle, this angle, and measure BCA angle. Do that and find out what happens. So you will realize when we measure BXY angle and BCA angle, these two are equal. So you will realize BXY angle is equal to BCA angle. So what are those? These are corresponding angles. When corresponding angles are equal, you will realize this line is parallel to this one. So XY, you will see this line is parallel to CA line. So this is corresponding angles. Now, what happens XY length and CA length? You will realize if this one is 5 centimeter, this becomes double of that. So, measure and see. So, you will realize what's the relationship between these two. AC length is double of XY. So, you need to construct this triangle and see these properties. We'll take another one. So, you have given PQR triangle. So, this length is 5 centimeter, 5 centimeter, and this is 4 and 4. And here, when you do that, when you construct this triangle, you will realize this is like the hypotenuse and this is for right angle triangle with hypotenuse 5 and one side is 4. What do you think about this side? You will get this one is 3 centimeters. So here when you measure, when you do this one, you can see this one is 3 centimeters with this one is 90-degree angle. Then if this is the case, what is QR? What do you think? These are two midpoints, and connecting the two midpoints of two lines is parallel to this one. So you will realize the QR length is double of this one. So this becomes 6 centimeters. Then what is XY? You will get XY as 3 centimeters. Then what is R angle? So if this is 90 degrees, this is also 90 degrees. Corresponding angles. Then PYX angle. PYX angle is also 90 degrees. So this becomes 90 degrees. So do that and see. When you construct a triangle like this, you will get 5, 4. Definitely this length should be 3 centimeters. Another triangle, KLM triangle. It says this is 3 centimeter, this is 3. So this is the midpoint. I'll take as P and this one is Q. What is KM length? Now again, can you see this is 4, this is 3. So this is like the right angle triangle with 4, 3. So these are triplets, 4, 3. Then this becomes 5 centimeters. If this is 4 centimeter, 3 centimeter, PQ becomes 5 centimeters. Then what is KM? If this is 5 centimeter, you will get double as this. So this is, if you take the bigger triangle, you can prove that also. 4, 4, this becomes 8. Here 6. Use Pythagoras theorem. 8 squared plus 6 squared and take the square root. 64 plus 36. That becomes 100. 100 square root is 10. So you will get this one as 10 centimeters or whatever the unit. I'll take centimeter for all. Then this becomes 10 centimeters. So what is PQ? PQ is always half of this. So you get 5 centimeters. And if you measure the angle, if KML is 57, KML angle is 57, what's this angle? QPL angle. You will get the same angle as this, 57. So this is also 57 degrees. So what is P? Midpoint of LM. Q is midpoint of KL. When you connect the two midpoints, this is the line segment through the midpoints. That's PQ. So the first theorem related to midpoints. So what it says, the straight line segment through the midpoints of two sides of a triangle is parallel to the third side and equal in length to half of it. So we'll try to prove that. So first thing, you need to take a triangle ABC. And we'll take AB midpoint is P and AC midpoint is Q. And PQ is the line segment joining the midpoints. Now we know these two information. P is the midpoint of AB and Q is the midpoint of AC. That information we already know. Then we need to do a small construction. So what you need to prove? You need to prove, to be proved, PQ is parallel to BC. It says the third side, this is the third side. The third side is parallel to the line segment joining the midpoints and the length is half of it. So here if PQ and the next one you need to prove this is PQ is half of the third side. Third side is BC. So we'll try to prove that with a small construction. I'll do the construction. Write down construction. We need to extend. So the construction is we are drawing a parallel line through C to AB. So we are drawing a parallel line through C to AB and PQ produced and this line meets at R point. So that's the construction. So we'll write down construction here. What's the construction? PQ produced and the line passing through C to AB meets at R. So that's the construction. Now we are trying to prove that these two. So the first thing we have to do is take these two triangles and we are trying to prove that these two triangles are congruent. If these two triangles are congruent, you can show that this length is equal to this length and we know this is same as this. So this is equal to this and parallel as well. If two lengths are, if the pair of opposite sides parallel and equal, we can say PRCB is a parallelogram. If it's a parallelogram, we know that BC is parallel to PQ or PR. So that's what we are trying to do. So we'll first take APQ triangle and CQR. CQR triangle. What you know? We know these two lines are parallel. So this angle is equal to this angle. So what are those? Those are alternate angles. PAQ angle is equal to QCR angle because of alternate angles. Then we know AQ is equal to QC. That's given because Q is the midpoint of AC. Then what else we know? We know this angle is equal to this angle. Opposite angles are equal. So we can write AQP angle is equal to RQC angle. That's opposite angles. Then what you can say? Angle, angle, side. Therefore, APQ triangle is congruent to CQR triangle. Then, if these two are congruent, what can you say about the corresponding elements? Corresponding elements are equal. So, what can you say about these corresponding elements? We can say, therefore, here, what's the reason? You have to write down why these two triangles are congruent. Angle, angle, side. Two angles and one side. Then we can say AP is equal to CR. Corresponding elements are equal. Then, if these two sides are equal, we can say AP is also equal to PB. Then, the left hand side is equal, so we can write CR is equal to PB. Then, PB is equal to CR. So, this is also equal. Then, BP or PB is parallel to CR. That's given. Pair of opposite sides parallel and equal, we can say PB CR. is a parallelogram. So we know this is a parallelogram. If it's a parallelogram, what can you say about the other opposite sides? Those are equal and parallel. So we can say, therefore, BC is parallel to PR or PQ. We can write instead of PR, PQ. Now we prove this one, PQ parallel to BC. So this is opposite sides of a parallelogram. Now, how can we prove this is half BC? We'll take this one. Now we know this length, corresponding elements opposite to this angle and this angle, PQ also equal to QR. Those are the two corresponding elements. So we can say PQ is equal to QR. That's also corresponding elements. Then what is PR? We can say PR is equal to BC or BC equals PR, opposite sides of a parallelogram, that's equal, but BC is what? PQ plus QR. I can write instead of PR, PQ plus QR. But from the previous one, we know PQ is equal to QR. I can rewrite this one as PQ. Instead of QR, I can write PQ. So BC is equal to 2PQ. So what is PQ? PQ is half of BC. So we prove that when you join the two midpoints of two sides of a triangle, the third side is parallel to the line segment connecting the midpoints, as well as the length is double of the line segment passing through the midpoints, or the other way, this length, the line joining the two midpoints, is half of the third side. So remember this theorem, and we'll try to apply this theorem in several examples. Take this example number 1. You have given ABC triangle and it says equilateral triangle. All sides are equal and length 12 centimeter is represented in the above figure. So all these lengths 12 centimeters. The midpoints of AB and AC are X and Y respectively. Determine the following: the length of XY. Now we know this is midpoint. So what is this length? 6, and this is 6. Here also the length is 12. Equilateral triangle. So this is 6, this is 6. So what about BC? BC is also 12 centimeters. According to the first theorem, midpoint theorem, what can you say about XY? XY is half of BC. The third side is BC. Half of BC. So this is according to midpoint theorem. Then we know BC is 12. 12 divided by 2, you get 6 centimeter for XY. Then the second part, they ask the perimeter of the quadrilateral BCYX. BCYX. So how can we find out the perimeter? We need to know all these lengths. We know so what's the perimeter? Perimeter of BCYX is equal to, just add all the lengths. 12 for BC, then 6, then XY we found that 6 and XB is 6. Just add all these, that's the perimeter of the quadrilateral BCYX. 12 plus 6, 18. 18 plus 12, 30 centimeters, because the lengths are given in centimeters. So the perimeter is 30 centimeters. Take exercise 11.1. First question, determine the value of x in each figure. So D and E are midpoints. We can see that. We can apply the midpoint theorem. If this is the line joining midpoints, so that's equal to half of the third side. Third side is given 15. So DE is x. So what's x? 15 divided by 2 is 7.5 centimeters. So here we can write down the reason as midpoint theorem. Second example, look at carefully. E and D given as midpoints. So this is the third side, BC. So what can you say about BC? BC length is double of this one, opposite of the other way. ED is half of BC. So what is BC? Double of ED. So we can write 2 times ED. Then BC is equal to x. X is equal to 2 times 6. That's 12 centimeters. The reason is again midpoint theorem. Take the third example. Look at carefully. What is P and Q? P and Q are both midpoints. So you can apply the PQ length is the line segment passing through the midpoints, and LM is the third side of the triangle. So what can you say? 42 is equal to double of the other side, double of 2x minus 1. So solve it and find out x. So we can multiply this by 2. 4x minus 2 is equal to 42. Take minus 2 to this side. 44 is equal to 4x. So what is x? Divide by 4. You get 44 divided by 4 is 11 centimeters. What's the reason? Midpoint theorem. Question number 2. In the figure, x, y and z are the midpoints. All these 3 are midpoints. So what can we write? This is equal to this. This is equal to this one, and this side is equal to this side. Then MN, NL, LM respectively of the triangle LMN. If MN is 8 centimeters, this is 8 centimeters. So definitely we know this is 4 and this is 4. NL is 10. So what is this side? This is 5, and this is 5. And LM is 12. So this becomes 6 and 6 because X, Y, Z are the midpoints. Find the perimeter of the triangle X, Y, Z. Which triangle we want? This triangle, the perimeter of this triangle. So how can we find out? What can you say about ZY length? ZY length is half of MN according to midpoint theorem. But we know half of MN is 8. Half of 8 is 4 centimeters. That's this length. Now apply the same thing for the other side. What is ZX? This one is half of LN. What is LN? LN is 10. Half of 10 is 5 centimeters. And what about the other side? XY. XY is half of LM. So what's LM? LM given as 12. Half of 12. So what's the answer? 2 and 12, 6. That's 6 centimeters. So how can we find out the perimeter of XYZ triangle? So the perimeter of XYZ is just add these three lengths. 4 plus 6 plus 5. That's 15 centimeters. So the answer for this question is 15 centimeters. Question number 3. In the quadrilateral ABCD, AC is 15, BD is 10. Find the perimeter of the quadrilateral that is obtained by joining the midpoints of the sides AB, BC, CD and DA. So ABCD is a quadrilateral. We don't know what shape of quadrilateral is. A, B, C, D. Any quadrilateral. AC is 15. This is 15. BD, this one is given 10. Find the perimeter of the quadrilateral that is obtained by joining the midpoints of the sides AB, BC, we put Y here, CD, XYZ, CD and DA. I'll take AB, XYZ and U, any letter U. Now they are asking what's the perimeter of this figure. Perimeter of this figure. Now we know these things. Now here I'll take this one as this side. We know U, Z, Y, X are all midpoints. If you take this triangle, what can you say about this? I'll take this triangle. A, C, D triangle. U is the midpoint. Z is the midpoint. The line joining the two midpoints is always parallel to the third side as well as the length is half of the third side. So straight away you can find out UZ length is half of 15. So you can straight away find out UZ is half of 15 according to midpoint theorem. Then we can apply the same thing to the other triangle, ACB triangle. So when you take this way, this is the midpoint. So XY is also the line segment joining the two midpoints. So what can you say about XY length? That's half of 15. And what about the other triangles? When you take other way, DBC triangle, this way, Z and Y both are midpoints. So this is 10. So what can you say about YZ length? That's half of 10. And also when you take ABD triangle, what can you say about XU length? Half of 10. When you find all the values and add it together, you get the perimeter of the XYZU quadrilateral. So find out 15 divided by 2, I can write 7.5. Here also 7.5. 10 divided by 2, I get 5 centimeters. Here 5 centimeters. So what's the perimeter? Perimeter of UXYZ quadrilateral. Straight away I can add these two, add all these lengths, 7.5 plus 7.5 plus 5 and 5, you get 15 plus 10, 25. So this is in centimeters, so you can write down the perimeter also in centimeters. So 25 centimeters. Fourth one, based on information in the figure, if the perimeter of ABC is 22 centimeters, AB is 8 and BC is 10 centimeters, find the perimeter of the triangle PBQ. So you are asked to find out the perimeter of this triangle. Now write down the information given. ABC triangle is 22, but we know AB is 8. So this is 4 because P is the midpoint. BC is 10. This is 5 and this is 5. Then perimeter of ABC is 22. So what is AC length? We can find out AC length is 22. That's the total minus 8 and 10. So what's the answer? 22 minus 18. That's 4 centimeters. So this is 4 centimeters. Now, how can we find out PQ length? PQ length is half of AC. Half of AC according to midpoint theorem. Then what is AC? We found this is 4 times half, you get 2 centimeters. Now we need the perimeter of PBQ triangle. So perimeter PBQ triangle is, just add 4 centimeters plus 5 centimeters plus PQ length. We found that's 2. So the answer is 11 centimeters. 4 plus 5, 9. 9 plus 2, 11 centimeters. Then part 2. If B angle is 40, C angle is 65. Find the remaining angles in the quadrilateral PQCA. So you are asked to find out the angles, these ones. PQCA quadrilateral, the angles inside that. Okay, how can we find out? Take ABC triangle. From ABC triangle, we can find out this angle, A angle. How? We know these two angles. So 180 is the sum of all three angles. So A angle is 180 minus 40 plus 65. So you get 5 here, 10. So 180 minus 105. You get 75 degrees for A angle. So you can write this is sum of angles in a triangle. That's 180 degrees. That's this angle. We know according to midpoint theorem, these two are parallel. So if this is 65, this is 65. Or what are the angles? Corresponding angles. So we can find out the Q angle. PQC angle. PQC angle is 180 minus 65. So straight away you can write down 180 minus 65 because that's a straight angle. Straight angle. So what's the value? You get 5, 1 remaining 7, 1. So 115 degrees for Q angle. So this is okay and this is okay. How can we find out this angle? This angle is the sum of these two angles. According to exterior angle, we can write APQ angle is equal to 40 plus 65. So you get 5 here and 10. 105 degrees for this angle. What's the reason? Sum of interior opposite angles add up to get the exterior angle. So exterior, you can write just exterior angle. So what are the angles? A is 75, Q angle is 115 and P angle is 105. Now you can check whether your answers are correct by adding all the 4 angles. That should be equal to 360. So we'll check that. 75, 115, 105 and 65. When you add all these, you get 360 degrees. That's the sum of angles in a quadrilateral. Question number 5. The midpoints of the sides QR and QP of the triangle PQR in the figure are M and L. QR plus QP. QR plus QP, these two lengths given 16 centimeters and PR is 2A centimeters. LN is B centimeter and this is 90 degree given. The first part they ask, find the perimeter of the quadrilateral LMRP. 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 So this big one, LMRP perimeter in terms of A. Now we know this length is 2A. So according to midpoint theorem, what is LM? LM is half of PR. So half of 2A, that's 1A or A. Then we know that QR plus QP is 16. That's given. When you divide the whole equation by 2, you get QR divided by 2, QP divided by 2, 16 divided by 2. What is QR divided by 2? QR divided by 2 is MR. So you can write this is MR. QP divided by 2, you can write PL. So the sum of MR and LP, that's equal to 16 divided by 2 is 8. Now we know these two lengths is equal to 8 and this is 2A and this is A. So what's the perimeter? Perimeter of LMRP quadrilateral. MR plus PL, that's 8, plus 2A plus LM, we found A. So you get 8 plus 2A and A becomes 3A. So that's the perimeter of LMRP. Now we'll try to do the second part. Express the area of LMRP. LMRP in terms of A and B. What's the shape? We know according to midpoint theorem, this line parallel to this line. So we can write LM is parallel to PR according to midpoint theorem. So this is a trapezium. So we get LMRP is a trapezium because one pair of lines are parallel. Then how can we find out the area of the trapezium? Area is the at the lengths of two parallel lines. That's A plus 2A divided by 2 multiplied by the perpendicular height. Perpendicular height is ln, that's given B centimeters. So what's the area? A and 2A becomes 3A divided by 2 into B. So the answer is 3AB over 2. What's the area? What's the unit? Square centimeters, because all the lengths given in centimeters. Question number 6. The triangle LMN has been formed by joining the midpoints LMN. So that means this length is equal to this one is equal to this one, and this one is equal to this one. PR, all these midpoints given. The triangle ABC has been formed by joining the midpoints ABC of the sides. So these also midpoints. So I can use another color. This one is equal to this one. So here these lengths also equal. If the perimeter of the triangle PQR is 12, find the perimeter of the triangle ABC. Now look at carefully all the, when you look at the big triangle PQR triangle, what can you say about ML? ML length is half of this. And what about this one? Half of PR. This one is half of that. When you take again MLN triangle, again joining midpoints, what can you say about the AC triangle? Half of that. So AB also half of that. So we can find out easily the perimeter of ABC using midpoint theorem. So when you take PQR triangle, we know the perimeter is 12. So I can write PR plus QR plus PQ is 12 centimeters. So I can find out easily by dividing the whole equation by 2, the length, the perimeter of LMN triangle. So half of QP, that's half of PQ is LN. Half of QR is ML. And half of PR is MN. That's equal to 6. 12 divided by 2. Again, I want to divide this by 2. The whole equation, divide this by 2. MN. Divide by 2. We know AB is half of MN. So, MN divided by 2 is AB. ML divided by 2 is BC. LN divided by 2 is AC. So 6 divided by 2, you get 3 centimeters as the perimeter of ABC triangle. So why all these we can use according to midpoint theorem. So this is a nice example. If you are trying to find out the perimeter that belongs this triangle, what you think? If you want to find out the perimeter of the triangle belongs this whole triangle, what do you think? That should be double of 12. So when it reduces, it becomes smaller and smaller. Always you divide by 2. So the bigger one is 24. The next one is 12. 12 divided by 2, 6. 6 divided by 2, 3. So that's a good example and a nice property when you think about midpoints. Question number 7. The midpoints of sides AB and AC of the triangle ABC in the figure are P and Q. Respectively, show that the areas of the triangles PBC, this triangle, and BQC, this triangle. Areas are equal. Now, when you draw a line joining this one, what can you say about ABC triangle? We know that this is the midpoint of AB and this is the midpoint of AC. So the line joining the two midpoints is parallel to BC. So we know PQ is parallel to BC as well as PQ length is half of BC according to midpoint theorem. Now, we found out these two lines are parallel. Now, when you look at BQC triangle, the area is equal to PBC triangle. We can straight away write down. Why? The two triangles in between the same parallel lines with base BC. So we can write down why these two areas are equal. Triangles are in the same set of parallel lines PQ and BC and with same base BC. So we can straight away write down the areas of the two triangles are equal. Question number 8. The perimeter of the square PQRS in the figure is 60. Find the perimeter of the quadrilateral that is formed by joining the midpoints of the sides of the square and express it in surd form. So they are asking if we join the midpoints, you get another quadrilateral and you are asked to, you get another square. Find the perimeter of this quadrilateral. We know all four sides equal to 60 centimeter. That's given. Perimeter of PQRS is 60 centimeters. Now, how can we find out one side? Length of one side is you divide by 4 because both four sides are equal. So 60 divided by 4, you get 15 centimeters. So this is 15. So 15 means, what is this length? Midpoint is this part, so 15 divided by 2. This is also 15 divided by 2. All these lengths, half of it, 15 divided by 2. Now look at the smaller triangle, the right angle triangle. This is 15 over 2. This is 15 over 2. You can find out this length. The length of a side of the other square is this one. If we put A, what's the theorem we can use? Right angle triangle, we can use Pythagoras theorem. According to Pythagoras theorem, this squared is equal to square one side and square the other side and add it. So what you get? 15 squared is 225. 2 squared is 4. 15 squared is 225 over 4. That's equal to A squared. 225, you get 450 divided by 4. So what's 450 divided by 4? We'll keep as it is and then take the square root. So what is A? square root of a square. A is square root of 450 over 4. What's square root of 450? So we'll try to simplify 450. What's the square number we can write? We can write divide by 5, we get 90. Divide by 5 again. 18. Divide by 3. 6. Divide by 3 again. 2. So we get, what's this square number? You get 5 times 3, 15 is the square number. So 450, you can write 15 times 15, 225 times 2. So when you write down, when you take the square root, you get 15 root 2 is 450 square root. So I can write down 450 square root is 15 root 2 over square root of 4 is 2. So what's the length of one side of the square that is formed by connecting the midpoints? That's 15 root 2 over 2. So what's the perimeter? They ask the perimeter of the square. Perimeter of the square formed you need to multiply this by 4 because 4 sides are there. So according to the figure, 4 sides, equal sides are there. So we can write one side is 15 root 2 over 2 multiplied by 4. When you multiply by 4, 2 and 2 get cancelled out and you get 2 here. 15 times 2, 30. 30 root 2. So what's the unit? This is perimeter. So that's centimeters. So 30 root 2 centimeters is the perimeter of the square formed by connecting the midpoints of the other square. Example number 1. MN and L are the midpoints of the sides AB, BC and CA respectively of the triangle ABC. Prove that NCLM, this one is a parallelogram. So we need to prove that this is a parallelogram. Now, according to the midpoint theorem, when you take ABC triangle, what you know about ML side and BC side? These two are parallel. So we know these two are parallel. And also, what you know about ML? That's equal to half of BC. Half of BC according to midpoint theorem. Now, we need to show these two are equal. Then we know pair of sides, one pair of sides equal and parallel, we know that's a parallelogram. So if we can show NC is equal to ML, we can show that's a parallelogram. So ML is half BC. I can write half. BC I can write BN plus NC. These two. But we know BN is same as NC. So I can write half BN. Instead of BN, I can write NC. NC and NC becomes 2NC. 2NC divided by 2, you get ml is equal to NC. Now, we know that the pair of parallel sides, the pair of opposite sides are parallel as well as equal. So, ml is equal to NC, ml is parallel to NC. So, therefore, we can write ml, or we can write NCLM. NCLM is a parallelogram. What's the reason? Pair of opposite sides equal and parallel. Exercise 11.2. P is a point inside the triangle ABC. The midpoints of AP is Z, so this equal to this, and the midpoint of BP is X. So this length is equal to this one, and the midpoint of PC is Y. These two are equal. Show that BAC angle is equal to XZY. XZY. So we'll connect that triangle and see. So they are asking to show this angle is equal to this angle and ACB angle is equal to ZY. These two angles and these two angles are equal, and show that the perimeter of the triangle ABC is twice the perimeter of triangle XYZ. Now we'll take ABP triangle. We'll take a different color. I'll take black color. We'll take this triangle. This triangle. ABP triangle. What can you say about AB length and XZ length? This is the midpoint, this is also midpoint. So XC is the midpoint, the line joining the midpoint. So what can you say about the two lines AB and XC? Both are parallel, as well as XZ is half of AB. According to midpoint theorem, then what can you say about this angle? This angle is equal to this angle because alternate angles are equal. So these two lines are parallel, therefore we can write BAP angle is equal to XZP angle. Alternate angles. Now we'll take the other side of the triangle, this triangle. I'll take another color. I'll take red one. This one. APC triangle. What can I say about AC and YZ. AC is parallel to YZ as well as YZ is half of AC according to midpoint theorem. Now, same thing, I can write this angle and this angle. When I take PAC, PAC angle is equal to PZY angle. That's alternate angles. Now, I want to add this one and this one. When I add these two, what am I getting? BAP angle plus PAC angle. So, when you add these two, I am getting BAP angle plus PAC angle this side, and the other side XZP angle plus PZY angle. I am getting the whole angle here, XZY angle here, and this one is BAC angle. So that's the first one. This one we proved. So you don't need to prove the other two angles, because when you take the other way triangle, you can easily show that when you take the other way, these two triangles, when you take this triangle with the other one, you can find out the same thing about this angle, and this angle is equal to this and this. So because of that, you don't need to do it again. You can write down similarly, because same procedure. Similarly, we can show that ACB angle is equal to ZYX as well as CBA angle is equal to YXC angle. Now we'll try to prove the next one, part 2. Show that, so this is part 1, show that the perimeter of the triangle ABC is twice the perimeter of triangle XYZ. From this information, XZ, YZ, you can write down what is XZ plus XYZ plus XC, YZ and XY. You can straight away write down XC is half of AB. We did that before. XY, we can do the same thing for XY. XY is half of BC and YZ. YZ is half of AC. So here I'll change the order. This is YC, XY. So XY here, YZ. Because YZ is half of AC. Then I can take half outside, AB plus BC plus AC. What's that? XC plus XY plus YC. What's that? Perimeter of XYZ triangle. So left hand side you get perimeter of XYZ triangle is half of AB plus BC plus CA is the perimeter of ABC triangle. So, show that the perimeter of the triangle ABC. Then, what's the perimeter of ABC? You can multiply by 2. So, perimeter of ABC becomes 2 times the perimeter of XYZ triangle. So, that's what it says. Show that the perimeter of triangle ABC is twice the perimeter of XYZ. Question number 2. The bisector of the angle QPR. QPR. So, if this is X, this is X. The bisector meets the side QR at S such that PS is perpendicular to QR. The midpoint of QT. The midpoint of QT is F. This length is equal to this length. Prove that FS is parallel to TR. So here, look at carefully. This is the midpoint of QT. F is the midpoint. If we can show that QS is also equal to SR, according to midpoint theorem, we can show that FS is parallel to TR. So, first thing you have to show that QS is equal to SR. So, we'll take the two triangles PQS triangle and PSR triangle, these two. What can you say about the triangles? We know QPS is equal to SPR. It's given. Bisector is PS. And PS is common. Then what else we know? We know that this angle is 90. PSQ angle, PSR angle is 90 degrees. That's also given. Two sides and angle. So, one side and two angles. Two angles and one side. Angle, angle, side. So, we can say PQS triangle is congruent to PSR triangle. What's the case? Angle, angle, side. So, if the two triangles are congruent, what can you say about the congruent elements? Congruent elements are equal. So, therefore, QS is equal to SR corresponding elements. So, corresponding elements are equal. So, we showed that this length is equal to this length. Now, what can you say about QTR triangle? QTR triangle, we know F and S both are midpoints of two sides. According to midpoint theorem, we can straight away write down FS is parallel to TR. What's the reason? Reason is because of midpoint theorem. So that's the proof. Question number 3. Based on the information in the figure, prove that PM, this one, is perpendicular to LN. So this is 90 degrees. And also, can you see L and N are midpoints, M also midpoints. So when you look at carefully the PQR triangle, what can you say about LN? LN length is parallel to QR according to midpoint theorem. These two lengths are parallel. And also, these all lengths are equal. Can you see? According to the figure, we can see that PQ and PR are both equal. So, same length given. So, if we take PQM triangle and PMR triangle, what can you say about the two triangles? We can see PQ is equal to PR, that's given, and PM is common. So we know PM is common length, and also M is the midpoint of QR. We can see that QM is equal to MR. These two lengths are equal. So we can say, according to given information, all three corresponding sides are equal. So we can write PQM triangle is congruent to PMR triangle. What's the case? Side, side, side. So we can say these two are congruent. If these two are congruent, what we can say about this angle and this angle? Corresponding angles are equal. So corresponding elements are equal in congruent triangles. So we can write PMQ angle is same as PMR angle. That's because of corresponding elements of the congruent triangle. If these two are equal, if this is x and this is x, we can write x plus x is 180. That's a straight angle. So 2x equals 180, x equals 180 divided by 2, that's 90 degrees. So one angle is 90 degrees. So QMP angle is 90 degrees. So we found out this is 90 degrees. This is 90 degrees. This is also 90 degrees. And we know these two are parallel. So what can you say about this angle? This is also 90 degrees. These two are 90 degrees because of corresponding angles. So we can straight away write down PM side is perpendicular to either QR or LN. So we need LN, so straight away we can write PM is perpendicular to LN. So we'll write down why this angle also. P, we'll put another letter PTL. We'll write PTL angle. PTL angle is equal to 90 degrees because of corresponding angles. So that's how we can prove that the two lines are perpendicular. Question number 4. Based on the information in the figure, prove that PLM triangle is congruent to QLM. So we need to connect this line. So you are asked to show that these two triangles are congruent. So we'll take that PLM triangle and QLM triangle. What do you know? We know PL is equal to LQ. That's given. And LM is common. What else we know? Look at carefully. We know, according to midpoint theorem, when you connect the two midpoints, this line is parallel to this one. So LM parallel to QR, as well as if these two are parallel, what can you say about this angle? This is 90 degrees. If this is 90, this is 90. So we can write PLM angle is 90 because of corresponding angles. Now we know this is 90, so this is also 90. So when you take the two triangles, I can write PLM angle is equal to QLM angle, that's 90 degrees because of corresponding angles. Now, two lengths and the included angle. We can straight away write PLM triangle is congruent to QLM triangle, side angle, side. That's the first part. And the second part, it says area of the quadrilateral LQRM is 3/4 of PQR. So the area. Now we'll take that quadrilateral LQRM. This one. What's the shape? That's a trapezium because we know that these two lengths are parallel. So that's a trapezium. So we'll find out LMRQ trapezium area. How can we find out? We can add the two parallel lines LM plus QR divided by 2 and multiplied by the perpendicular height, that's LQ. What is LM? LM is half of QR according to midpoint theorem. So we'll write LM is half QR, or I can write the other way, it's easy for you. QR is double of LM. 2LM instead of QR into LQ. Now we'll take that and see what is LM plus 2LM. You get 3 LM over 2 into LQ. How can I write LM in terms of QR? I can write LM is half of QR. And what's LQ? LQ is half of PQ because L is the midpoint. I can write LQ as half of PQ. So I want to substitute these two in this equation. This is all because of midpoint theorem and midpoint. Now we'll plug it here. 3 over 2. Instead of LM, I want to write half QR. And instead of LQ, I want to write half of PQ. Now, when I take this one separately, this becomes 3 over 4, 2 times 2, 4, and you get half PQ into QR. What's that? Half into PQ into QR. PQ into QR, these are perpendicular. So that's the area of PQR triangle. So I can write this one is 3/4 of area of PQR triangle. So that's what they want. So the area of the quadrilateral is equal to 3/4 of area of PQR. Question number 5. The midpoints of the sides AB and AC of the triangles ABC are Q and R. So that means this length is equal to this one. So this length is equal to this one. This length is equal to this one. And the midpoints of the sides AQ and AR of the triangle AQR are P and S. This length is equal to this one. This length is equal to this one. Prove that 4PS is equal to BC. So we'll put a length A for that. If this is A, this is also A. If this is B, this is B. But we know AQ is equal to QB. AQ, QB. So what is QB? QB becomes A and A. This is 2A and this is 2B. And also, when you take this big triangle, what can you say about the other lengths? When you take ABC triangle, midpoints are Q and R. When you connect the midpoints according to midpoint theorem, we know that QR is half of BC. Midpoint theorem. Then take AQR triangle. Again we know P and S are midpoints. When you connect the midpoints, again we can say PS is half of QR. Same thing, midpoint theorem. Now we'll try this one with this one. Substitute instead of QR this one. when you take 1 and 2, what can you say about PS? Half of QR. Instead of QR, I'm writing half of BC. So half and half, you get 1/4. BC is PS. When you cross multiply, what you get? 4 PS is equal to BC. So that's what you need. 4 of PC, 4 of PS is equal to the length of BC. Question number 6, part 1. Prove that the quadrilateral that is formed by joining the midpoints of the sides of a quadrilateral is a parallelogram. So we'll first draw any quadrilateral. We'll take A, B, C, D. And the line joining midpoints. So we'll take, this is X, Y, Z and U. Okay. Then this is equal to this one is equal to this one, this length is equal to this one, and this length is equal to this length. And they're asking, show that the line joining the midpoints is a parallelogram. So X, Y, Z, U is a parallelogram. So you have to show that. Prove, to be proved. X, Y, Z, U is a parallelogram. Now look at carefully. When I construct this line, AC line, join that AC line, what I can say about these two lengths? Now look at carefully. X is the midpoint of AB and U is the midpoint of BC. So according to midpoint theorem, we can say that XU is equal to half of AC as well as XU is parallel to AC. So according to midpoint theorem. So this line is parallel to this one. When you take ABC triangle. Now take the other side, ACD triangle. What can you say? So when you take ACD triangle, again Y and Z are midpoints. When you join the two midpoints, the line YZ is parallel to AC as well as YZ is half of AC. Again, midpoint theorem. Now what can you say about AC and these two lines? AC is parallel to YZ, AC is parallel to XU. So from these two I can write XU is parallel to YZ. Again, when you take lengths, this is half AC, half AC. So you can say XU is equal to YZ. These are the opposite sides of a quadrilateral. A pair of opposite sides equal and parallel. What can you say about the quadrilateral? That's a parallelogram. So we can write XYZU, XYZU is a parallelogram. What's the reason? Pair of opposite sides equal and parallel. So that's why when you join midpoints of a quadrilateral, you get a parallelogram. So this side is parallel to this side as well as this length is equal to this length. A pair of opposite sides equal and parallel. Now we'll take the second part. Now second part, it says prove that the quadrilateral that is formed by joining the midpoints of the sides of a rectangle. Now the quadrilateral is the rectangle. Now you have given a rectangle. We'll take A, B, C, D. And the midpoints, when you join the midpoints, X, Y, Z, U, when you join the midpoints, you have to show that that's a rhombus. What's the property of a rhombus? Rhombus means it's a parallelogram with all sides are equal. So we need to show that XYZU is a rhombus. We know this length is equal to this one. Opposite sides are equal in a rectangle. So these sides are equal. This side is equal to this one. So this is equal to this one. Now we'll try to prove the sides are equal. From the first part, we found out when you take any quadrilateral and when you join the midpoints of the quadrilateral, you get a parallelogram. So straight away from part 1, I can write XYZU is a parallelogram. Now I have to show that the sides are equal. Now take the diagonal AC. When you take the diagonal AC, what can you say about XY? We know that according to midpoint theorem, XY is half of AC. What about this one? What is XU? Half of PT. So these according to midpoint theorem. Now this is a rectangle. What can you say about diagonals? Diagonals are equal in a rectangle. We know that AC length is equal to BD because diagonals are equal in a rectangle. Then what can you write about this one? This side is equal to this one. So you get AC is 2XY is equal to 2XU. 2 get cancelled out. XY is equal to XU. XY length. This length and this length both are equal. So this is a parallelogram with equal adjacent sides. That means this is all sides are equal and it's a rhombus. So we can write these are adjacent sides of a parallelogram. So adjacent sides are equal means all sides are equal in XYZU parallelogram. So that therefore you can write down XYZU is a rhombus. Parallelogram with equal sides we call that's a rhombus. Next part, prove that the quadrilateral that is formed by joining the midpoints of the sides of a square is another square. Now the shape is a square. So all sides are equal. Now we'll take midpoints as XY, ZU. What can you say about these? All lengths are equal because in a square all sides are equal. When you take midpoints, the lengths are also equal. Now connect this one and see what happens. Now this is also becomes a square. So how you prove that this is a square? If we can show adjacent sides are equal and each angle is 90 degrees, we can say that's a square. Now how can we show this is 90 degrees? Now we'll connect. We take ABCD is the square. We'll connect these BD and AC diagonals. We know in a square the diagonals bisect at 90 degree angle. So diagonals bisect. So AC perpendicular to BD line. We can write diagonals bisect at 90 degrees. Now again, when you take ABD triangle, what can you say about ABD triangle? We can see according to midpoint theorem, XY is parallel to BD as well as it's parallel to, when you take the other triangle, it's parallel to UZ. I'll first do this one. XY is parallel to BD and XY is half of BD. You have to do the same thing that you did in part 2. And BDC triangle, when you take, you can see UZ is half of BD as well as UZ is parallel to BD. So all these because of midpoint theorem. Now opposite side, a pair of opposite sides parallel and equal. Can you see half BD, half D? You can see XY is equal to UZ as well as XY is parallel to UZ. It's a parallelogram and these two lengths are equal. You can do the same thing to the other side. Now XY is, that's a parallelogram. And how can we show that these are equal, adjacent sides are equal? Again, we can write down AC is equal to BD. Diagonals are equal in a square. So diagonals are equal means we can show that, similar to part 2, xy is equal to xu because AC is same as BD. We know that these are equal. How can we show that one angle is 90 degrees? Look at carefully. If this is parallel to this one, what can you say about this angle? This line is parallel to this one, so you get this is 90 degrees. So this is also 90 degrees. Allied angles add up to 180. So here we get this is 90, this is also 90, this is 90 and this is also 90. So what's the reason? We can write down xy is parallel to BD as well as parallel to UZ. All these three lines are parallel. So allied angles add up to 180. So we know this angle is 90 because of corresponding angles, and this is 90 because of allied angles. So we can show that all angles 90 degrees. So we can say y x u and x u z and u z y as well as z y x, all angles 90 degrees. So all sides are equal and 90 degrees. Therefore, x, y, z, u is a square. Now we'll take the last part. Prove that the quadrilateral that is formed by joining the midpoints of sides of a rhombus is a rectangle. So rhombus now. We'll take x, y, z, u, same points, and this is A, B, C, D. This is a rhombus means all sides are equal. So we can say this length is equal to this one. All these lengths are equal, same length. Now, when you take the quadrilateral, from the first step straight away you can write down this is a parallelogram. X, Y, Z, U is a parallelogram. If this is a rectangle, we need to show that opposite sides are equal and parallel, that's a parallelogram, and we have to show that these all are 90 degrees. So how can we show these are 90 degrees? Again, using the same procedure we used in previous part. When you take these two lines, XY is parallel to AC, and when you take this line, UZ also parallel. And if these two are parallel, xy and these are parallel, and we know in a rhombus BD is perpendicular to AC. That's the main point here. Diagonals bisect at 90 degrees. Diagonals bisect at 90 degrees. So this is 90 means according to corresponding angles, this is 90, this is 90, and allied angles again, this is 90. So we can say D, we'll put O or something, DOA angle, DOA angle is 90 because of diagonals bisect at 90, and then because of that this angle, this is 90, X, we'll put T or something, XTC angle is also 90 according to corresponding angles. If this is 90, this is also 90 because these are parallel lines. Allied angles add up to 180. So therefore, we can write UXY angle is 90 degrees according to allied angles. So we found out this is a parallelogram as well as one angle is 90 degrees. So what's the shape? A quadrilateral with each angle 90 degrees. What you say? It's a rectangle. So we can write down X, Y, Z, U is a rectangle because each angle 90 degrees. So those are the four things. So it's a good property when you take any quadrilateral and when you join the midpoints of a quadrilateral, you get a parallelogram. If you take a rhombus and when you do that, you get a rectangle. When you take a square and do that, you get another square. And what is the previous one we did? We did, if it's a rectangle, you get a rhombus. So that's a good property when you take any quadrilateral. Now we'll look at the converse theorem of midpoint theorem. In converse theorem, it says the straight line through the midpoint of one side of a triangle and parallel to another side bisects the third side. So here, if you draw the triangle, it says if there's a triangle, the straight line through the midpoint of one side. If this is ABC, so X is the midpoint of one side of a triangle and parallel to another side, So here if you draw a line parallel to this side, another side bisects the third side. Bisects means this length is equal to this length. So we'll try to prove that. So here, what you know about this? We know X is the midpoint of AB, and also we know if this is Y, XY is parallel to BC. That's given. So we need to draw a construction like before. Can you remember the construction? We extend XY produced and the line parallel to AB through C. So this line and this line both are parallel and this line meets at R. So we'll write XY produced and line through C parallel to AB intersects at R point. So that's the construction and you need to prove that AY equals YC because bisect means these two lengths are equal and we'll start to prove that. Now again, if we can show that these two triangles are congruent, this length is equal to this length. Those are corresponding elements. So what are the information we know? We know that XRCB is a parallelogram. What's the reason? XY is parallel to BC. It's given. And also by construction, we know that AB is parallel to RC. These two lines are parallel. So you can write XRCB is a parallelogram. Because opposite sides are parallel. Then what can you say about these two lines are parallel? So this angle is equal to this angle. This one is equal to this one, opposite angles. And what else we know? This side is equal to this side. And this side is equal to this one. So CR is equal to AX. So we'll write down when you take AX Y triangle, AXY triangle and YRC triangle. YRC triangle, we can write XAY angle is equal to YCR angle. That's alternate angle. Also, AYX angle is equal to RYC angle, opposite angles. Then we know BX, I'll do it here, BX is equal to CR because of the parallelogram, opposite sides of a parallelogram. But we know BX is equal to AX. From these two, we can write down AX is equal to CR. So here, from these information, two angles and one side. So we can say AXY triangle is congruent to YR YRC triangle. What's the case? Angle, side. Two angles and one side. So therefore, these two are congruent means corresponding elements are equal. So what are the corresponding elements? AY opposite to this angle, opposite to this angle. So AY equals YC. We can write because of corresponding elements. Corresponding elements are equal. So that means this line bisect each other. AC bisect with XY line. So that's the converse of midpoint theorem. So in midpoint theorem, you know one midpoint and the parallel line drawn to the third side. So that line and this one bisect the other side. So we'll use this theorem, converse theorem, in several examples and see. In example 1, the bisector of the angle BAC of the triangle ABC. ABC triangle, the bisector A angle is AD. Here, this one meets BC at D. So this angle is equal to this angle. ADB is 90 degrees. The straight line through D parallel to AC meets the side AB at E point. Prove that ADB triangle, ADB, we'll draw it. This triangle ADB triangle is congruent to ADC triangle. So these two. So we'll do the first part. We'll take ADB triangle and ADC triangle. What can you say about those two triangles? We know BAD angle is same as DAC angle. It's given. Angle bisector. Then AD is common. And also we know that ADB angle is equal to ADC angle, that's 90 degrees. That's also given. If this is 90, this is also 90. So we can say these two are congruent. ADB triangle is congruent to ADC triangle. What's the reason? Two angles and one side. Angle, side. Then the second part, BE. BE is equal to EA. Now we found out these two triangles are congruent. Then corresponding elements are equal. So here if you take BD and DC, both are equal. Those are corresponding elements. Now we know these two are equal. Then according to converse theorem, converse midpoint theorem, when you take midpoint of one side and when we draw the parallel line to the other side, the side bisect, this third side bisect each other. So that means according to midpoint theorem, converse of midpoint theorem, we can write BE equals EA because BD equals DC and DE line is parallel to CA according to converse. Now we can write converse midpoint theorem. Converse midpoint theorem, we know that it bisects each other. So BE should be equal to EA. Now take example 2. P is the midpoint of the side BC, this one, and the midpoint of AP. Midpoint of AP is Q. BQ produced meets the side AC at R. The line through P parallel to BR meets AC at S. If AC equals 15 centimeters, AC is 15 centimeters. Find the length of AS, this one. Now we'll look at this one. When you take BRC triangle, this one, what can you say about RS and SC? According to converse theorem, BP is PC and these two lines are parallel. You can say RS is equal to SC. RC line bisect with the PS line. So that's because of converse theorem. So I can put this length is equal to this length. Then now we'll take APS triangle. What can you say about APS triangle? APS triangle. Q is the midpoint and these two lines are parallel. These two lines are parallel and these two are equal. According to converse midpoint theorem, I can write AR is equal to RS. Converse theorem. Then we know RS is equal to SC, RS equal to AR. So therefore I can say AR is equal to RS, that's equal to SC. All these three lengths are equal. So what can you say about AS now? If this is A, this is A, this is A. So what is AS? So that's A. AS we need now. AS is A plus A. A plus A, that's 2A. Now what is A? 3A equals 15. 3A equals 15. So what is A? 15 divided by 3, you get 5 centimeters. So substitute here, 2 times 5 centimeters is 10 centimeters. So AS length is 10 centimeters. Exercise 11.3. Find the value of x in each figure. Now look at the first one. These two lengths are equal and these two are parallel. According to converse theorem, what's MZ? That's also same length. So we can write XL is equal to LY, LM parallel to YZ. Converse midpoint theorem. XM is equal to MZ. So X equals 3 centimeters. So this is same as this length. Look at the next one. This length is equal to this length, 6 centimeters given. And this line is parallel to this one. So again, converse midpoint theorem. So what is X? Straight away we can write X is 5 centimeters. So write down Px is same as XQ, XY parallel to QR according to converse midpoint theorem. I can write Py is equal to YR. So that's X equals 5. Look at the next question. Again, this side is equal to this side. And these two angles are equal. What can you say about the two lines? Then these two lines are parallel because corresponding angles are equal. So if these two are parallel, that means X equals 3 centimeters. So what's the reason? We can write AE is equal to EC and DEA angle is B equals to BCE angle. It's given and corresponding angles are equal. So therefore we can say BC is parallel to DE. So then you can use the converse midpoint theorem to find out the X value. Question number 2. The midpoint of the side AC of the triangle ABC is P. Already marked. BC is 12. This is 12 centimeters. AB is 15. PQ is parallel to CB. Find the length of QB. Look at carefully. This is the midpoint. AP is equal to PC given and PQ is parallel to CB. So what can you say about these two lengths? Therefore, we can say AQ is equal to QB according to converse midpoint theorem. Then we know these two are equal. So what is QB? So first one, QB equals half of 15. So 15 divided by 2, you get 7.5 centimeters. Then the next one, they ask the length of PQ. PQ. Now we know this is also midpoint. So we know PQ is half of PC. Half of PC according to midpoint theorem. Then BC is 12. Half of 12 is 6 centimeters. So PQ is 6 centimeters. Question number 3. L is the midpoint of side AB of the triangle ABC in the figure. LM is parallel to BC and MN parallel to AB. If AB is 10, this is 10, AM is 7 and BC is 12. Find the length of MC, this one, and the perimeter of BNML. Quadrilateral. BNML quadrilateral. What's the first thing? Now, when you take ABC triangle, we know AL is equal to LB and LM is parallel to BC. Parallel, and this is the midpoint. So, what can you say about AM and MC? AM equals MC according to Converse midpoint theorem. Then, if these two are equal, what is the length of MC? MC is half of AC. AC length is 7, half of 7. You get 3.5 centimeters for MC length. And now we need to find out the perimeter of BNML quadrilateral. That's a parallelogram. Here all sides are parallel. That means a parallelogram. How can we find out? We know LM is half of BC. Half of BC is 12, so that's 6 centimeters. So this is 6 centimeters. Opposite sides are equal, so this is also 6 centimeters. So I can write BN also 6 centimeters. Then if you take AB and MN, MN is half of AB according to midpoint theorem. So these two according to midpoint theorem. What is AB? AB is given 10. Half of 10 is 5 centimeters. So we found this is 5. So this is also 5 because LMNB is a parallelogram. Because LM is parallel to BN, LB is parallel to MN. All are given. So what's the perimeter? So perimeter of BNML. BNML is 6 plus 6 plus 5 plus 5. So you get 11 plus 11, 22 centimeters for the perimeter. Question number 4. Based on the information in the figure, and if AC is 10 centimeters, so this is 10, we'll put this one 10. AD is 8, this length is 8, ML is 10. This one is 10. Find the length of DC. Look at ACD triangle. This is a right angle triangle. This length is 10, this is 8, and this is CD. So you can use Pythagoras theorem. According to Pythagoras theorem, we can say x squared plus 8 squared is equal to hypotenuse squared, that's 10 squared. So x squared plus 64 is equal to 100. So x squared becomes 100 minus 64, that's 36. So x is square root of 36 plus or minus 6 centimeters, but these are lengths. So x is positive 6 because length cannot be negative. So we found out x equals 6 centimeters. So that's the length of DC. Now look at the second part. You need ABCD area. So to find out area, we need to find out the AB length. Now when you take ABC triangle, this is parallel to this one and these two are equal. Midpoint, one midpoint and parallel line given. That means, we'll put a K point here. That means CK is equal to KA according to Converse theorem. Converse midpoint theorem. Now take CDA triangle. CDA triangle. Now we know this length is equal to this length and these two are parallel. Then you can use the Converse theorem again and write down DL is equal to LA, and if these two are midpoints, we know that CD is equal to double of KL. So CD is 6. So what is KL? Half of that. Half of that is 3 centimeters. So KL is 3 centimeters. So we found this is 3. If this is 3 and the whole thing is 10, what can you say about MK distance? MK is equal to 7 centimeters because 10 minus 3. Now again, take ABC triangle. When you take ABC triangle, we know this is 7. So what can you say about AB length? AB length is double of MK length according to midpoint theorem. So 7 times 2, you get 14 centimeters for AB length. So we can write this is according to midpoint theorem. Now we can find out the area of the trapezium. Area of ABCD trapezium. Add the two lengths, parallel lengths, that means 6 plus 14, divide by 2 and multiply by the perpendicular height. Perpendicular height is 8. So 6 plus 14 is 20. 20 divided by 2 multiplied by 8, you get 80 square centimeters, because this is in centimeters, so the unit is square centimeters. So the answer is 80 square centimeters. Question number 5. The perimeter of the equilateral triangle ABC. So this is an equilateral triangle, is given 30 centimeters. Based on the information in the figure, find the perimeter of the trapezium BCYX. Now, we know the perimeter of the equilateral triangle is 30. So, what is one side? If one side is A, 3A, because all sides are equal, 3A is equal to 30. So, what is A? 30 divided by 3. That's 10 centimeters. One length is 10 centimeters. So, we know BC is 10 centimeters. And here, look at the given information. This length is equal to this one and this line is parallel. According to Converse midpoint theorem, we can say this is also equal. So, we can write AY is equal to YC because of Converse midpoint theorem. Because AX is equal to XB and XY is parallel to BC. Now we know this side is 10. So half of that, this is 5, this is 5, this is 5 and this is 5. Then what about XY? XY is, according to midpoint theorem, XY is half of BC. Again, half of 10 is 5 centimeters. So, we know this is also 5. So, what's the perimeter of BCYX trapezium? We can add all the lengths. 5 plus 5 plus 5 plus 10. You get 25 centimeters for the perimeter of the trapezium. Question number 6. ABC and ADC in the figure are equilateral triangles. ABC and ADC. These two are equilateral triangles. All sides are equal. AB is 20. So, this length is 20 means this is 20, this is 20 and all these lengths are 20 because of equilateral triangle. Based on the information in the figure, find the perimeter of the region PQ, RD, CP, this region. So, we need to find out these lengths. We know PQ is half of BC according to midpoint theorem. Can you see that? This is parallel and these are equal. So, that means this is also equal. So, PQ is half of BC, half of 20. You get 10 centimeters for this length. Then RQ is also half of DC, half of 20, that's 10 centimeters. Why? This is parallel to this one and this is the midpoint. So, definitely this is half of that according to midpoint theorem. And these also equal. This is equal to this side. Now, we can add all sides to get the perimeter. So, perimeter of PQR DCB quadrilateral, not a quadrilateral, 1, 2, 3, 4, 5, 6. 6-sided polygon. What's the perimeter? So, we'll add all the sides, 20. This becomes 10, half of 20, another 10, another 10, This is also 10, half of 20 and 20 again. So see how many 10s are there? 1, 2, 3, 4. 4 10s and 2 20s. So what's the answer? 40, 60 and 80. 80 centimeters is the perimeter of this figure. Question number 7. Find the length of MN, this length, based on the information in the figure. If PQ is 20 centimeters. Okay, first we need to draw a line, construct a line so that it's parallel to MN and parallel to PQ. We need to draw that, otherwise we can't do at once. I'll take this one as T. So we are drawing LT parallel line to MN. Now what we can say about LT length? LT length. We need to take the full PQR triangle. PQR triangle, LT is equal to half of PQ according to midpoint theorem. Can you see? If this length is equal to this one and this is parallel, so definitely this side is also equal. Then according to midpoint theorem, you can write down that's half of it. So half of 20, you get 10 centimeters. Now look at PLT triangle. PLT triangle, this length is equal to this one and these two lines are parallel. What can you say about this one? According to the triangle Converse theorem, this is equal to this one, then MN is equal to half of LT. But we know LT is 10 centimeters. So half of 10 is 5 centimeter for the MN length. So all these because of Converse theorem and Converse midpoint theorem and the midpoint theorem. Question number 8. Based on the information in the figure, express the length of PQ in terms of the lengths of AB and DC. We'll connect B and D. What can you say about ABD triangle? We can say this length is equal to this one and this one is parallel to this one. According to Converse midpoint theorem, we can put a letter here T. What can you say about PT? PT is half of AB. Converse midpoint theorem and then midpoint theorem. Then when you take the Converse theorem, we can say this length is equal to this one. Then take BDC triangle. When you take DC triangle, this length is equal to this one and this line is parallel to this one. Again, we can use the midpoint and the converse midpoint theorem and write down TQ is half of CD. This is also same reason. But we want PQ. What is PQ length? PT plus TQ. PT we can write half AB and TQ is half CD, or I can write DC. Then when you take half out, I can write AB plus DC is equal to PQ length. So you are asked to give PQ length in terms of AB and DC. Question number 9. The length of a side of the equilateral triangle ABC. So all sides are equal. Is x centimeters. It says length is x. So if this length is x, what is this one? X over 2, x over 2. This is x and this is also x. And if EF length is y. Based on the information in the figure, express the following in terms of x and y. The perimeter of EDGF. EDGF is this one. To find out the perimeter, we need to find out the lengths. Now, look at ABD triangle. We can show that ABD triangle and ADC triangles are congruent because these sides are equal, this is equal and this is common. These are congruent, so this is 90 degrees. So this is a right angle triangle. One side is x over 2, this side is x. So how can we find out this length? AD length. You can use Pythagoras theorem. So AD squared plus x over 2 squared is equal to x squared. So AD squared is equal to x squared minus, take it to the other side, x squared over 4. 2 squared is 4. Then I can write as 4x squared over 4 minus x squared over 4. 4x squared minus x squared, I get 3x squared over 4. Then when I take the square root, I get root 3x over 2. Square root of 4 is 2. So this is AD is this value. Then what is ED? ED is half of it. Half of root 3x over 2. So you get root 3 over 4x as ED. When you take BCF triangle, what can you say about these two lengths? These two are equal because BD is equal to this one and these two lines are parallel. So we can say this length is equal to this. So BCF triangle, FG is equal to GC. And if you take the other triangle, this one, this triangle, again we can say AF is equal to FG because of this midpoint and the parallel line. This is parallel and this is midpoint. So I can write Both these because of Converse midpoint theorem. Now, what can you say about Fg? So, according to this one, Fg is equal to AF is equal to GC. All three sides are equal. One side is x. So, what is Fg? Fg is x over 3. So, this is x over 3, x over 3, x over 3. So, Fg is equal to x over 3. And also we know that this is y, EF is y. So, what is DG? DG length is twice of EF, that's 2y. So, we have all the lengths. So, what is the perimeter of EDGF? Add all together. So, we have ED, that's root 3 over 4x plus y plus another 2y plus and x over 3. So, I can take x terms together and write down this answer as the first part as I can write 2y and y becomes 3y plus root 3x over 4 plus x over 3. Now, what's part 2? The perimeter of BDGF. BDGF. So, we'll take another color, black one, BDGF. This one. Now, how can we find out this one? We found out this is 2y. So, according to midpoint theorem, this is double of that. So, this becomes 4y. Then, this is x over 2 and this is x over 3. So, what's the answer for the second part? 4y plus 2y plus x over 2 plus x over 3. So, when you add, you get 6y plus here common denominator is 6. So, you can convert to 6. This is 3x, 3 times 2 and this is 2x. So, you get 6y plus 5x over 6. Now, the third part, perimeter of BDGA. BDGA. So, the bigger length. So, we'll take red color. BDGA now. This one. So, what's the perimeter? We have x over 2. This is 2y. And what is this length? X over 3 plus x over 3? 2x over 3. Now, add all together. The common denominator is 6. So, third part I can write 2y plus 6 is the common denominator. So, this is 6x over 6. You get 1x. This is 3 times 2, so 3x. This one is multiplied by 2, you get 4x. So, what's the final answer? 2y plus 6 plus 4, 10 plus 3, 13x over 6. So, 2y plus 13x over 6. Question number 10. The midpoint of the side PQ of the triangle PQR in the figure is T. So, this is midpoint. So, this distance is equal to this one. And also, the straight line T and the S is the midpoint of PT. So this is equal to this, and this if it's A, this is A, this becomes 2A because this distance is equal to this one. And T drawn parallel to QR, the straight line through S and T drawn parallel to QR meet the side PR at V and U respectively. Prove that PV is equal to 1/4 of PR. Now we'll look at PQR triangle. When you take PQR triangle, PT is equal to TQ and TU is parallel to QR. According to Converse midpoint theorem, we can say PU is equal to UR. Converse midpoint theorem. Then what can you say about the other side? If you take PTU triangle, again same thing happens. This is the midpoint and these two lines are parallel. So we can say PV is equal to VU. Converse theorem. So this is equal to this one, and if this is B, this is B, and this is also equal to this one, this becomes 2B. Now we can find out PV. PV is equal to B, and what is PR? PR equals B plus B plus 2B, 4B. So when you divide these two, PV over PR is equal to B over 4B. B get cancelled out, you get 1/4. So what is PV? 1/4 of PR. That's what we need. Then second part, determine the ratio SV to QR. Now according to midpoint theorem, we know SV is half of TU. Again, if you take the bigger triangle PQR, we know QR is half of T. Other way around. So this is wrong. So we can say when you take the bigger triangle TU, or I can write QR is double of TU. Double of TU is QR. Now we'll divide these two. What happens? SV over QR is equal to half TU divided by 2 TU. TU get cancelled out. Half divided by 2. Half divided by 2 is same as half multiplied by the reciprocal. Half, you get 1/4. So this is 1/4. So SV to QR. As a ratio, I can write SV to Q. R is equal to 1/4. Question number 11. Based on the information in the figure, prove that AR is equal to RP, So this is AR equals RP, and PS is parallel to BQ. These two lengths are parallel. This one parallel to this one, and this one parallel to this one. So what can you say about PCSQ quadrilateral? It's a parallelogram because opposite sides are parallel. Then we can write PC is equal to QS. Opposite sides are equal. And also QS is equal to BP as well. So PC is equal to BP. So here also we can say Q, according to these two, QS is equal to BP, and also we know QS is parallel to BP. Therefore, BPSQ is a parallelogram. So this is a parallelogram means this one is parallel to this one as well. Now, and also we know PS is equal to BQ. This length is equal to this one, and I'll put two lines here. Then what we need, according to this one, ASPQ, also a parallelogram. This length is equal to this length. So I can write ASPQ is also a parallelogram. So PS is equal to AQ. So that means these two are equal. Now, what can you say about this point? This point is a midpoint. So we can say AR is equal to RP according to Converse midpoint theorem. That's the first part. And you have to show that PS is parallel to AB. We did that before. So here, according to this one, PS, we took PS somewhere there. So here we found that AS, this one is a parallelogram. So PS is parallel to AB or same as BQ. So that's how we can prove that AR is equal to RP and PS is parallel to BQ. Miscellaneous exercise. Question number 1. The midpoints of the sides PS and QR. QR is this one. Of the parallelogram PQRS. PQRS is a parallelogram. That means these two sides are parallel, these two sides are parallel, and X and Y are midpoints. So I'll mark This length is equal to this one, this length. Here same side, opposite sides are equal, I can use the same length. This is equal to this. Then the lines XQ and SY meet the diagonal PR at L and M respectively. Prove that XQ YS is a parallelogram. We need to show this is a parallelogram. How can we show that? Here we can see that opposite side is equal and parallel. So we'll write down PQRS is a parallelogram. So PS is equal to RQ, and also we can write SX is equal to XP, that's equal to RY, that's equal to YQ. Because of a parallelogram, opposite sides are equal and XY are midpoints. XY are midpoints. Then according to this information, we can see that XS is equal to YQ as well as XS parallel to YQ. Pair of sides equal and parallel. Pair of one side. Equal and parallel. Therefore, we can say XQYS is a parallelogram. That's first part. Second part, prove that PM is equal to 2/3 of PR. Now look at carefully. Now this is a parallelogram. So what we can say about these two lines, this is also parallel. These two sides are parallel. Now we'll take PSM triangle. PSM triangle. This length is equal to this. So PSM triangle. This is equal to this one and these two are parallel. What can you say about these two lengths? These two lengths are equal according to Converse midpoint theorem. So if this is A, this is A. So I can write PL is equal to LM, that's A according to Converse midpoint theorem. Then what can I say about PR? PR is the diagonal of PQRS parallelogram. Take this one, PLQR triangle. When you take LQR triangle, what can you say about LQR triangle? this length is equal to this length and these two lines are parallel, I can say this length is equal to this one. So I can write MR is equal to ML, that's A according to Converse midpoint theorem. Now, what is PR? PR, I got A plus A plus A, that's 3A. What is A? A means now we need the ratio between PM and PR. What is PM? PM is 2A. Now when you divide these two, 1 and 2, what you get? 1 divided by 2, I get PR over PM equals 3A over 2A. A get cancelled out. I need PM. Cross multiply. 3 PM is equal to 2 PR. And then what is PM? I can take 3 down. 2 PR over 3. So 2/3 PR is equal to PM. Question number 2. The midpoints of the sides BC and CD are M and N. This length is equal to this one. This side is equal to this one. The straight line MN intersects the diagonal AC at L. Prove that LC is equal to 1/4 of AC. I'll connect this diagonal BD. What can I say about DCB triangle? This is the midpoint, DN equals NC and CM equals MB. Midpoints connect with NM line. So that's parallel to DB as well as the length is half of DB according to midpoint theorem. So according to midpoint theorem, I can write down NM parallel to DB as well as NM length. So NM is parallel to DB, and also we know that when you take DC, I'll put O here, DCO triangle, these two are parallel and this is the midpoint. According to Converse theorem, what can I say about OL and LC? These two lengths are equal. I'll put A and A here. This is because of Converse midpoint theorem. This one because of midpoint theorem. Now, we found these two are equal. And this is ABCD is a parallelogram. We know that diagonals bisect each other. So ABCD is a parallelogram. We know AO equals OC. OC is 2A, so this becomes 2A because diagonals bisect. Now, what can we say about LC? LC is A and AC is the full length of AC, 2A, A and A, 4A. When you divide these two, what you get? 1 divided by 2. LC divided by AC is A over 4A. A get cancelled out. We can write LC is 1/4 of AC. So we can say LC is 1/4 of AC. Question number 3. Based on the information in the figure, prove that the following. QN is equal to NO. So we can take this triangle. Look at this triangle. QRO triangle. QL is equal to LR. That's given. And LN is parallel to RO. It's given. This is parallel and this is equal. According to Converse midpoint theorem, we can say QN is equal to NO. So Converse midpoint theorem. Then part 2. PNLO is a parallelogram. PNLO. So we'll take with a different color. PNLO is a parallelogram. If we can show that these two lengths are equal, we know diagonals bisect each other in a parallelogram. So we have to prove that M is equal to MO. To do that, we need to take POM triangle. We have to do this part first. We have to show that POM triangle is congruent to NLM triangle. We'll do that part first. Third part first, to show that this is a parallelogram. According to this triangle, we know that PM is equal to ML. It's given. Then this angle is equal to this angle because these two lines are parallel. NLM, I'll write here, NLM angle is equal to MPO. MPO. MPO angle. MPO angle. Those are alternate angles. And then this angle is equal to this angle. LML MN angle is equal to PMO angle. Here, this should be this side. I'll write it properly. So I'll write down, this is PMO triangle. So this angle, PMO angle is same as NML angle. Those are opposite angles. Then two angles and one side. So we can say POM triangle is congruent to NLM triangle. What's the case? Angle, angle, side. Angle, angle, side. So we found out these two triangles are congruent. Then we can say LM is equal to MO. Those are corresponding elements. Corresponding elements are equal. Then we found these two also equal. So diagonals bisect each other. We can say POLN. POLN. POLN is a parallelogram because of diagonals bisect each other. You can write because of NM is equal to MO, and also PM is ML. So that's the second part. But we did the third part here as well. So you can refer same thing here. The third one is the two triangles are congruent. Now the fourth part is MO is equal to 1/4 of QO. So that's fourth part. Now third part we can write in part 2. And fourth part. Now when you look at OQR triangle, what can you say about OQR triangle? Look at carefully. When you take OQR triangle, look at this one, this is equal to this one, and these two are parallel. What can you say about QN and NO? Both are equal according to Converse midpoint theorem. So if this is 2A, this becomes 2A. So this is because of Converse midpoint theorem. Now we got QN is 2A. I'll write this is equal to 2A. Then what is MO? MO is equal to, according to this one, this is A. And what is QO? QO is 2, 3, 4, 4A. So when you divide these two, what you get? 1 divided by 2, you get MO over QO is equal to A over 4A. A get cancelled out and I'm getting MO is equal to 1/4 of QO. That's what you need to show. MO is equal to 1/4 of QO. Question number 4. PQR is a parallelogram. So we need to draw the diagram because the diagram is not given. So we'll draw it. PQRS is a parallelogram. Its diagonals intersect at O. These two sides are equal. This side is equal to this one. This is parallel. We can mark all the given information. Parallelogram means opposite sides are parallel, equal, and the diagonals bisect each other. So I can show that information as well. I'll put In black, these two are equal. Then the midpoint of the side PQ is L. The midpoint of LO, this one is T. So this one is equal to this one. PT produced and QR, PT produced meets QR at Y. So when you draw PT produced, this is meets at Y. Prove that PT is equal to TY. So this is T. I'll use a different color. This point is T and this is Y. First part, it says show that PT equals TY. Here look at carefully PQR triangle. We know that PO is equal to OR. That's the diagonal bisect each other, and PL is equal to LQ. So this is OL is the line joining the midpoints. So according to midpoint theorem, what can we say about the lines? We can say OL is parallel to QR. This is parallel to QR, as well as we can say OL is half of QR. We'll write down that also according to midpoint theorem. Now we found out this line is parallel to this line. Now take PYQ triangle. PYQ triangle, these two lengths are equal. PL is equal to LQ, that's the midpoint, and OL is parallel to QR, that's from the previous part. Now we can use Converse midpoint theorem and write down, what can we write down? We can write down PT is equal to TY. That's the first part. So this distance is equal to this one according to Converse midpoint theorem. Then the second part, PLYO. PLYO is a parallelogram. So we'll take a different color. PLYO. This one is a parallelogram. Here, if we can show that the diagonals bisect each other, we can definitely say PLYO is a parallelogram. So we'll use that property. We know that PT is equal to TY from part 1. And we know this information. LT is equal to TO. That's given in the figure. So diagonals bisect each other. So therefore PLYO. PLYO is a parallelogram. we can write down diagonals bisect each other. Now the third part. 4 LT. LT 4 is equal to QR. Now we know LO is half of QR according to midpoint theorem, and also what is LT? LT is half of LO. So I can write, instead of LO, I can write double of LT. So instead of LO, I can write double of LT because it's given. So from these two, I can write, instead of LO, 2LT is equal to half QR. So I can multiply this by 2. 2 times 2, 4LT, you get QR. So 4LT is equal to QR. Question number 5. Y and X are the midpoints of the sides PQ and PR respectively of the triangle PQR. So we'll draw the triangle PQR triangle. Y and X are the midpoints of the side PQ and PR. The lines QX, this one, and YR intersects each other at L. The straight line through Q parallel to YR meets PL produced at M. The lines LM, this is L, LM and QR intersects at N. So this is the diagram. And we need to mark these two information. These are midpoints. This is equal. And these two lines are parallel. First part, prove that PL is equal to LM. PL is equal to LM. So it's easy when you look at this triangle. Look at this triangle. We know this line is parallel to this one. And this one is equal to this one. So straight away we can write down YP equals YQ, that's given, and MQ is parallel to LY, both given. So therefore we can write PL is equal to LM according to Converse midpoint theorem. So you have to write down, this is because of PQM, when we are taking PQM triangle. So that's the first part. Second part, Prove that MR is parallel to QX. Now look at PMR triangle. We found out PL equals LN. This length is equal to this whole length. So we found out PL equals LM and PX is equal to XR. Now according to midpoint theorem, this is the line joining two midpoints. So we can say straight away LX is parallel to MR because of midpoint theorem. Then the next part, third part. Prove that QMRL is a parallelogram. So straight away we get it. Why? Opposite sides are parallel. Now see, this side is parallel to this side, QX. So here from the previous part we found that this one is parallel to this side and what's the other side? QMRL. So this one. This side is parallel to this one already given. So opposite sides are parallel means QMRL is a parallelogram. So we'll write down QMRL is a parallelogram. What's the reason? We found out MR is parallel to QX. QL or QX same thing from part 2. And we know QM is parallel to LR. So opposite sides are parallel. Opposite sides are parallel. So that means QMRL is a parallelogram. Now the fourth part, it says determine PL to PN. PL to PN. Here to here. Now look at the first part, PL to LN. LM, both are equal. So if this is A, this whole length is A from the first part. Now PL is equal to PN. Now look at this parallelogram. We know that this length is equal to this length. Diagonals bisect each other. So here if this whole length is LM is A, so we know this is A over 2, A over 2. Now we can find out the ratio. So we have to first write down all these information. So fourth one we can write down. PL equals LM. That's equal to, we'll put A from part 1. Then NL equals NM. What's the reason? Diagonal bisect each other because of QMRL parallelogram, because we found out that's a parallelogram. Now we'll put, if this is A, so this is A over 2, divide by 2. Now we'll take the ratio. PL is A and PN equals PN. Where's PN? PN. Up to here, A plus A over 2. A plus A over 2, you get, this is 2A over 2 plus A over 2 becomes 3A over 2. That's our second one. Divide PL and PN. What happens? A divided by 3A over 2. A get cancelled out. So 1 divided by 3 over 2. 1 divided by 3 over 2 becomes 1 multiplied by 2 over 3. Take the reciprocal. So you get, this is 2 over 3. So what's the ratio? PL to PN is 2/3. We discussed 2 theorems in this chapter. One is midpoint theorem and its converse. So do all the exercises and examples and thorough with the 2 theorems.